Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guide for Chapter 8, Test number 1. This is the study guide that's going to go over simple and compound interest. And if you recall, just simple interest is I equals PRT. It's straight multiplication process. You take the principal times the rate in decimal form times the number of times, or the time in whatever the time unit is. And once you multiply all those together, that tells you how much interest was earned over that period of time. Okay? If you need to find the new amount after the fact, the new amount is going to be equal to your interest earned plus the amount of principal that you started with. So you'd have to do that separate. For the compound interest formula, there is an exponent that is a part of the process. And so this is where you'd want to use a scientific calculator. And in the end of the process, it will tell you the new amount, where simple interest did not. Simple interest, you had to do an extra step in order to figure out what the new amount was, your new balance. But in compound interest, it happens automatically. So it really comes down to you understanding all the different parts, which you should have in your M&Ms, and you should also have in your notes from the work that we've done this past week on these concepts. But just remember, principal, P, that's the amount that you start with, whether it's you investing money into an account, like a savings account, or borrowing money for a loan. The interest rate is always given as a percent, and you convert that to a decimal number. The T is always going to be, well, actually it's T or the N, depending on which one that you choose to use. I always use the T, but that's the number of times or time periods that it has been compounded. And in this case, that's all you need for compound interest. The principal, the rate, and the time also happens here, and then the I represents the amount of interest earned, whereas A is your new amount. Okay, so the first 5 problems all have to do with simple interest. Let's double check this. Simple interest, blah, 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 blah. I guess this one doesn't say, but it is simple interest because the parents, oh yeah, it does right there. Simple interest. And this one should actually look familiar because I included this one in your assessment last Friday. This one is simple interest there with a horrible decimal number there, but that's not too hard to figure out. Simple interest here, and it says simple interest here. So all 5 of these situations involve simple interest. So how do we solve these problems? Well, let's go ahead and think about the 5D process. They should always give you your principal. They should always give you your rate. They should always give you your time period, and usually it seems like we're supposed to figure out the interest. However, what they really need to do is give you 3 of the 4. If they give you 3, you can always figure out the 4th because your 4th becomes your variable in your algebraic equation, and then you just solve for that variable. So taking a look at problem number 1 with Tom, he had $50. He loaned $50 for a month. So that's the amount of the principal is $50. He charged 5%, so we're going to change that to 0.05, 500ths. And that is for the month. And it's only for 1 month, right? So the time period is 1 month. So the interest that we're going to get is going to be I is going to be equal to 50 times 0.05 times 1. And 50 times 0.05, let's use the calculator to figure that out. 50 times 0.05 is $2.50. So if you said $2.50, you would be the winner if indeed they're asking how much interest will Jody have to pay on this loan. But that's not what they asked. They said, how much did Jody have to pay Tong? Well, she has to pay back the $50 plus the interest. So that's how you get $52.50. This is a problem from the assessment, and from the feedback that I heard from students, people thought this was relatively easy. So Parents are going to allow or deposit $2,000 into an account. So that's the dollar amount that her grandparents are agreeing to pay 7.5% simple interest on. So 7.5% becomes 0.075. And it is for every year per year for a total of 4 years. So we're going to put a 4 in here. And this is another one where we have to determine what the interest is and then decide what the question is asking. So we're going to take $2,000 times 7.5% for 4 years. So I'm going to start by figuring out what is 2,000 times 7.5%. 2,000 times 0.075 is $150. That means that her grandparents are agreeing to pay her $150 per month for 4 months. So you multiply those two together, and that's how you get your 600. So how much extra money? That would be the interest. You declare your answer as $600. Okay, so that's the basic simple interest, how simple interest works. Now, of course, you can get some situations where you have to deal with fractions, and people think, oh, no, I don't want to deal with a fraction. But 8 3/4%, 3/4 is the same as 75%, so that is 8.75%. So when you write that as the rate, it's going to be 0.0875, right? Because when you've changed from a percent to a decimal number, you're dividing by 100. 8.75% literally means 8.75 divided by 100. And just copy this down from your calculator or keep it in the calculator as you do your calculations. So David read an ad offering 8 3/4% simple interest on accounts over $500 left in for minimum of 5 years. So 500 times 0.0875 for a minimum of 5 years. So let's see what it is for 5 years. So I want to figure out what it is for 1 year. So I'm going to take this number times 500. That's the amount per year, and then multiply that times 5, $218.75. That's how much money he will earn in interest over that 5-year period. Okay, so I'm assuming at this point we've done 3 different examples. You should have the basics of how to use the formula I equals PRT whenever you see a problem that says simple interest. Now, last 5 problems all have to do with compound interest. We'll do 6 and 7, and then 8, 9, and 10 are on the back side. So the formula for compound interest, we take A, that's the new amount, is going to be our principal times 1 plus the interest rate in decimal form raised to the power of the number of times it's being compounded. So it says, no, we're not doing this one, we're doing this one. Christina decided she would do better if she put her money in the bank, which paid 2.8% interest compounded annually. All right, so this works in conjunction with problem number 5, where we think she's going to earn $438 on an account where she got $125, 3.5% per year. If she were to save it for at least 1 year, how much interest could, what, is that right? Hold on for a second. Hold on, I need to pause this. This seems weird. Aha, I'm so glad I looked at problem number 5, because guess who forgot to put a decimal point in here? When you take 125 at 3.5%, that would be 4.375, which of course we would round up to 0.38. For 1 year, there's supposed to be a decimal in there. It's supposed to be $4.38. All right, glad I saw that and fixed that. All right, so let's get back to this problem here. So Christina decided she would do better if she put her money in the bank, which paid 2.8% interest annually. Was she right? And the answer is no. Why? Because in 1 year, there's not going to be any difference between simple interest and compound interest if they have the exact same interest rate. It's after that where it would start to compound for the compound interest. The fact that this started off as a lower amount our new amount is going to be, let me change that, hold on for a second. I need a finer point pen. So the new amount is going to be your $125 times 1 point, and then this as a decimal number is 2.8 divided by 100 is that, and so I'll add that to the 1, and I get 1.028. So 1.028, and then this is only going to be for 1 year, right? Just saying 1 year. So if I use my scientific calculator for this, 125 times 1.028, and then you raise that to the power of 1, it's not, and whatever that is, it's going to stay as 1.028. So that's going to be $128.50, which means, since that's the new amount, 128 and what was that, 50 cents? 0.50, subtract away the principal, she's only going to make $3.50. So no, she would actually do better with simple interest because it's only 1 year, because the simple interest was higher than the compound interest. All right, suppose Jessica, from problem number 2, had put her $2,000 into a bank at 3.25% interest compounded annually for 4 years. So the principal is going to be the same for this problem, but the interest rate at what was it before? What did they agree to? Oh, 7.5. Wow, that's a good interest rate. This might actually give her less money. I don't know. Let's see. And then the time period is for, again, 4 years. So it's going to be compounded 4 times. So that's going to be 2,000 times 1.0325 raised to the 4th power. Let's see what she gets. Oh, well, that's what it's going to be. But no, I don't want this one. I want that one. So 2,000 times 1.0325 raised to the 4th power. And you get $2,272.95. Is that what I wrote down there? And yes, that's what I wrote down there. So how much would she have earned at the end of that time period? For this one, she earned $600. This one, she only earned $272.95. Why so much less? Because it was an extremely less interest rate. So the simple interest, it's going to take a lot of years before this lower interest rate compounds enough to surpass the 7.5 interest rate that she got up here. Okay, so a much higher interest rate goes a long way if it's simple interest. All right, I put in $4,250 into an account that paid 4.4% interest, and it's annually, and for 7 years means the formula is going to be our principal times 1 point, and then this as the decimal would be 0.44 raised to the 7th power. Put all that into your scientific calculator, 4250, 1.044 raised to the 7th power, no, raised to the 7th power. It's going to be $5,745.03. Okay. So, what should I do this one? Let's do this one. This is a fantastic one. I think these two, what is it? What's the difference in the amount of money after the bank for these two interest rates? So you just figure out each one of them and subtract. Shouldn't be too much trouble. You've seen me running through the process a number of times. But let's do Rana. I want to hear what this has to, how did that get so big? So Rana was listening to her parents talking about what a good deal compounded interest was for a retirement account. I agree. The sooner you start putting money into a retirement account and don't touch it, the longer it is going to be in that account. And those last few years of compounding before you retire is where you really see a lot of growth. So if you start putting money into a retirement account when you're 40, you're going to get like 20, 25 years, maybe 30 years of compounded interest. But if you start when you're 20, you're going to get like 45 or 50 years. Okay, so let's take a look at this situation. She wondered how much money she would have if she invested $2,000 when she was 20 years old at 2.8%, and it's going to be compounded quarterly, which means 4 times per year. And she left it in there until she was 65 years old. So that's a total of 45 years. But it's not, here, let's make sure we get this written in. The principal is a measly $2,000. Not a lot, right? But that's a pretty good interest rate. 2.8% for a savings account, that's pretty good. Now, I don't know, it was a retirement account, but still, I feel like that is a little bit high. But let's go ahead and write that in decimal form. And now the time is quarterly, so it's 4 times per year times 20 to 65 is 45 years. So that means this is going to get compounded 180 times. So we're going to take $2,000 times 1.028 and compound it 180 times. That's how you get that to be such a big number. Okay, so when you really think about it, like my retirement account that I have for working at the school, I'm putting in a certain amount of money every single week. No, every single month. Every single paycheck, a portion of my paycheck gets taken out and put into a retirement account. So I started teaching when I was 30 years old. So I've been having this chunk of money pulled out every single month for the last 23 years. And I'm going to continue probably for another 10, 12, maybe 15 years. And so we're looking at a good 32 to 35 years. And I'm pretty sure these accounts get compounded monthly. But it's a very much lower rate than this. Okay, it's not 2.8%. But the idea is, if you have an account where they automatically pull it out of your paycheck and you work solidly for 30, 40, 50 years, having that money deposited into a retirement account every single month, that's how you're going to have enough money to retire. And the more money you can put in at an early stage, the higher this is going to go. So my message to you is save your money. Don't spend it, right? Clothes and cars and vacations and restaurants are a lot of fun. And you should absolutely take care of yourself and enjoy life. But also find a way to save money every single month and put it into an account that will pay you interest. And if you are dedicated to putting money every single month into that account, it will grow for you. And you're going to find a lot more time to play when you're in your retirement years than someone who does not save money and has to work into their 70s and, like my poor dear mother, even into her 80s. But to be honest with you, she loves working. So it's one thing to be working because you have to pay the bills. It's another thing to work because you love working. So just keep that in mind. So any other questions? Please get in touch with me. We need to move on to our chapter test. So get your calculators ready. Make sure you record everything. Make sure that you feel really good about your answer, that your answers make sense before you submit that test. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,